Mice pie. Mice never tasted so delicious.
Let X be the number of cars owned by a randomly selected household from the United States. Assume that the possible values of X are 0, 1, 2, 3, and 5. The probability distribution of X is given below. And we want to find the variance of X. Can you find the variance of X? Let X be a discrete random variable with a probability mass function given in the table below. Here, x1 through xr are the possible values taken by X, and p1 to pr are the corresponding probability values. All these pi's are greater or equal than 0, less or equal than 1, and the summation is 1. Then, the expected value of X, denoted by E of X or mu, is defined to be here, this equation. Well, the variance denoted by VAR, variance of X or sigma square, is defined to be, well, this equation. Now, how can we find the variance? Okay, now there is a computationally easier way to calculate the value of variance. Now it's stated in the theorem below. If we let X be a random variable, then we have this equation. The variance of X equals the expectation of the square of X minus the square of the expectation of X. In other words, the variance equals the expectation of the square minus the square of the expectation. All right, let's repeat it one more time. The variance is the expectation of the square minus the square of the expectation. Now here, expectation of X can be found using this formula, and expectation of X squared can be found in this formula. Now, this method is usually computationally easier. Okay, let's see how we can use this method to calculate the variance. Now, what we can do is we can find these two expectations, expectation of X and expectation of X squared, simultaneously. How can we do that? Now, what we do is we add two rows, x p of x and x squared p of x, to the probability mass function table, like what we did here in blue. The third row is x of px, and the fourth row is x squared p of x. So you got the values here. And then the expectation of x and the expectation of x squared is simply take the summation of the corresponding items. So expectation of x is x1p1 plus x2p2 plus da 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 and plus xrpr. And the expectation of x squared is x1 squared p1 plus x2 squared p2 and plus da 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 and plus xr squared times pr. And after we got these values, we can find the variance using the theorem. The variance of x is simply equals the expectation of the square minus the square of the expectation. All right, that's how we can find the variance of a random variable, a discrete random variable. All right, it is just that easy. Add two rows find the expectation of x and find the expectation of the square of x, and using this equation, the variance of x equals the expectation of the square minus the square of the expectation. I got it? All right. Let's show how we can solve the problem we had at the beginning. Here is a problem. All right, X is the number of cars owned by a randomly selected household from the United States. We have the possible values of X are 0 through 5. The probability distribution of X is given below. We are to find the variance of X. How can we solve this? All right, like we said, we firstly add these two rules, x p of x and x squared p of x. So, as shown in this table in blue, we already added these two rules, and then we can calculate all these products, right? 0 times 0.1, 1 times 0.2, and so on, and 0 squared times 0.1, 1 squared times 0.2, and so on. So we can calculate all these values in the all these products in the table, and we get this one. Okay, so we got all these values, and then what we can do is we are to find the expectation of x and also the expectation of x squared. So expectation of x is the summation of the product in the third rule. So 0 plus 0.2 plus 0.8 plus 0.45 plus 0.4 plus 0.25, that's 2.10. And the expectation of x squared is the summation in the fourth row. So that's 0 plus 0.2 plus 1.6 plus 1.35 plus 1.60 plus 1.25. That is 6.00. Then, well, the variance can be found using the formula variance equals the expectation of the square minus the square of the expectation. That's 6.00 minus 2.10 squared, which is 1.59. So therefore, the variance of this number of this random variable is simply 1.59. In many cases, we are also trying to find the standard deviation, which is another measure of variability of a random variable. So what is the standard deviation? Now the standard deviation of a random variable x is defined to be the square root of its variance. It's often denoted by sigma. Now we have this equation, sigma equals square root of the variance. So you can see that it's pretty easy to find the standard deviation. So after we find the value of the variance, then we can find the standard deviation by taking the square root of the variance. That's just very simple, okay? So for instance, in our example, the variance is 1.59. So the standard deviation is sigma equals square root of the variance, which is square root of 1.59. That is 1.261 if we round to the third decimal places. So that's how we can find the variance and standard deviation of a discrete random variable. I hope you found this video helpful. Now, before you leave, why don't you try the following problem? Let x be a random variable with the following probability distribution, and find the value for c first, and then find the expectation, the variance, and the standard deviation. Can you solve this problem? Give it a try and leave a comment below. I will see you in the next episode. Thank you.